Okay, so let's take a look at just some quiz questions and see which ones really call to us that maybe will help us either know how to apply what we already know to these questions, or maybe help us sort out and hammer out the specific kind of flow chart we have in our mind, because this is the big challenge. Some of you just talked before I started the video here that this is the big challenge. One of the big challenges, at least, of this chapter is, what do I apply? What formula do I apply to this question? And B, what in the question it needs to go into the formula. So there's a lot of judgment and discernment that's being tested here, and the way to get good judgment and discernment is to do a lot of judging and discerning. And you have to, in my view, you just have to have a lot of experience with it, and then you know. In fact, that's what, not just my view, that's also the robot overlords who are going to overtake us, their view as well. That's how a machine learning algorithm that can differentiate a cat and a dog, that's what it does. It goes through 10,000 pictures of a cat and a dog to figure out how exactly the difference is, what exactly the difference is between them. And it gets pretty good. It can get pretty good differentiation and classification of those two categories. So likewise, we're also trying to figure out different categories of problem solving that we need to apply. Do I need to apply this style of problem solving? Do I need to apply this style of problem solving to these different questions? And so I'm going to try to see if we can go through some of them, as many of them as we can, with as much clarity as I can add to the process here to help our algorithms classify cats and dogs well, by analogy. To help us out. What, the open answer ones? Yeah, let's start with that. That's they often offer the really good some really good tests and tests of our skill, and they're harder. Less of an ability to say, well, I have a 1 in 4 chance, or I ruled this one out, so I have a 1 in 3 chance, or whatnot. All right, so let's start with, in fact, if you don't mind, I'd love to do all the open answer ones I can find on here and come back and hit any multiple choice that you see on this instantiation of the quiz that you want to look over. So let's start with this. We're going to start with, so this is a weird two-parter quiz. We got yield and mix, and we have overhead, and they have very little relationship to each other. Relatively little relationship to each other. So we got these 4 kind of categories of questions we're going to get, and we'll get a chance, based on what I saw from the open answer, to go over at least 3 of the 4, if not all 4 of the 4. Yield variance is the first one we're going to go over. So yield variance, first of all, let's remember, with yield variance, I'm at the end of the question, I'm going to have to figure out favorability, and it's going to be weird. All the signage is flipped. Now, for the open answer one, don't worry, that actually isn't part of the problem. It isn't part of the ways you can get this wrong, because you don't have to indicate favorability. On the multiple choice, you will have to indicate favorability, and so it's important that be activated, because you will have some questions that require. Okay, the other thing with yield variance is we've got the 3 different things we need to be contrasting. Three different terms. There we go. 3 different variables we're looking at. First of all, we're looking at what's in the parentheses, which is our actual yield of finished goods units and our standard yield of finished goods units. And outside the parentheses, we're looking at our standard input price at the standard mix. Now, I've given you the outside the parentheses one right here in this problem. I don't always do that, but in this one I've said, look, at the standard mix, standard input price per finished goods unit is $2.03. So we're saying that we have so many input units. Every finished goods should cost us $2.03 of input units worth of input units. The standard number of input units per finished goods is 6. Okay, so we should have, if we had 6 input units, we should get 1 finished goods unit out of that. The firm actually completed 30,000 finished goods units. Okay, so that's our actual yield right there. It's given to us. So we have 2 of the 3. Well, we're going to use these 2 numbers to figure out the third. So we have, in this particular problem, this is yield, open answer. We have our standard price at standard mix. Let's leave it at that. That's fine. 2.03. Oh, we have numlock. 2.03. We also have our actual yield. That's given to us. 30,000 input units. And so yield is a quantity of units, but hopefully giving it a different name helps us code it differently in our minds, because it's not the same thing as quantity that we've worked with in 7-1 and that we work with in the overhead problems. The quantity is always talking about the quantity of an input, quantity of direct materials units, quantity of direct labor units, or whatever. Yield, you can say that's always talking about, well, what do those inputs yield in terms of finished goods units? So our actual yield, when you see this phrase right here in the sentence, I want you to say, finished goods units being yielded, that's the number I'm looking for. That's the actual yield right here. Now the standard yield, in fact, we're going to move that down. We have to figure out based on standard. Let me use the terminology from the book. Make sure I'm not saying it so differently it confuses. This is right here, standard total output per standard input unit. So we have how many output we should have? 1/6. That's what it said in the problem here. It says we have 6 input units. Sorry, the number of input units per one finished goods unit is 6. So I don't have the number 1 right here, but it's singular finished goods unit. So 1 finished goods unit, 6 input units. And so 1 output or yield, 1 finished goods unit output over 6 input units. So 1/6. So standard total output. I can put it in the terminology I use in the book here like this. 1 finished goods unit. Standard total input. And I think most of the problems are phrased when they give you this kind of information of 1 finished goods unit per this number of input units. I think that's how they're usually phrased. All right, so the textbook here says we should take that 1 finished goods unit over the 6 standard input units and multiply that by the total actual input. So that what we're saying is, look, given the fact that we use 117,016 input units, we should be getting 1/6 of that in output units. That's how many finished goods units we should have produced with that. So 117,016, that's our actual input, actually in out, actual input. So I'm going to put, this is input units, FG units. And so we should just be able to say 1/6 times actual input. So it'll give us 19,502.67, rounding it off. That's how many finished goods units we should have been able to produce with this number of inputs. We should have ended up with just shy of 20,000. How much did we actually end up with? 30,000. Okay, so we're talking about yield, how many finished goods units are input yielded. This is a positive thing that we have the actual number is higher than the standard number here. So let's go ahead and follow that. Put parentheses. Follow this equation here. So that should be it right there. We have our actual yield. Just following the equation right here. Right here. We have our actual yield identified. We have our standard yield that we had to calculate. We had to take these 3 numbers, or I implied the 1. I gave you the 6 written out in the question, and I gave you the actual input. The 1 is implied in this expression right here. And that when we multiply those together or divide them together as given here, we get our standard yield, which now we have this number, all multiplied by the standard price at standard mix, which I gave you at the very beginning of the problem. Nope, now I messed it up. Times, must be 3. Okay, so that should be our yield variance. And again, the open answer questions for yield are all programmed so that they will be favorable variances, which means positive numbers, so that they should be anyway. I'm 99% sure I did that. So that you don't even aren't even tempted to put in a negative number. So I have that note in there as an extra redundancy, but you shouldn't even come up with a negative number. You should have a positive number, which in the yield variance world, only in yield variance, is a favorable variance. So I'll say this again real quick. I mean, we've got every other time we've held the output, the finished goods units, constant. We've said, okay, given this number of finished goods units we actually produced, we should have used this amount of input, direct materials or direct labor, to get that. That's how we've always done it. That's why it's positive is unfavorable and negative is favorable. Here on this side, this one type of variance, yield, we are holding constant instead the number of input units and letting flow actual versus expected output units, the finished goods units that are coming from those input units. And so that just makes it so that we have to interpret it oppositely. If we have more finished goods units out of the same number of input units, that's a positive thing. Is it at all confusing that I've made this very general and called them input units instead of saying like direct labor hours or pounds of direct materials? No? For some of us,
I think some of the more common when there's lots of variables, like lots of different numbers.
Yeah.
Sometimes that can be a little bit confusing.
Okay. Well, that's one interpretation you'll need to make in these problems. To when you see that, you can code it in yourself. In fact, let me come back to that in a second. Code it. That means some type of direct material, some type of direct labor, whatever it is we're talking about. I just kept it general, I think, in a lot of the in these problems for a lot of them. With 2 units, 2 types of, like this kind of one. Sure. Let's put this right here, and we'll come back to the open answer docket that we're working on. So this is a yield multiple choice question with 2 types of input units. So almost certainly what I'm trying to get at with this is I'm going to force you to calculate the standard price and standard mix with these two units. So we're going to use the same equation here, and these 2 sub-equations happen as well. So in fact, let's write them out just in case we have to use them. So standard yield equals standard total output divided by standard total input times actual input units. Let me come back and put units in a bunch of places here. Units. Okay, and then what we're going to have to do here is the standard price at standard mix, which is, I say it's standard price of a batch of input units divided by finished goods per batch. And this isn't a hard thing to do typically because we're usually talking about 1 finished good per batch. We're saying standard price of 1 finished good per batch of input units. In fact, maybe I don't even need to include that. Because in this question right here, we're going to say the standard price for a single finished goods unit based on the fact that a finished goods unit takes 2 units of A and 3 units of B at the price of $14 per unit of A and $20 per unit of B. We're going to get the total price it takes to get 1 finished goods unit. So that denominator is going to be 1. So we might as well just think of it as this right here. Standard price at standard mix equals that. So let's just put these to the side. These are extra equations from the textbook, if they help. All right, so we're looking for yield variance. We know that from the question stem here. And we know our actual yield is 12,000 finished goods units. Okay, we can grab that. Actual yield, 12,000 finished goods units. And, it looks like we have our actual input here, actual total input units of 150,000. it says here that per finished goods unit, since it's just unit 1, it's 1 unit, we have 15 input units. All right, so let's grab these two right here, copy them over, and we have 15 input units. Okay, so if we take this 1 divided by 15, so 1/15 the number of finished goods units versus the number of input units, multiply that by the input units, this should be our standard yield. Because we got 2 of the 3, and now the part where the two units actually matter, which was the question you had. So calculating this, we're gonna say we have input A. We have 2 units of input A. In fact, I want to put it back where I had it. There we go. We have mix, standard mix, input A, input B. So if we want, we can think of these as two types of labor. Maybe we have a lower skilled labor and a higher skilled labor, the way they're priced. And we're going to have them in a mix of 2 to 3. Every finished goods unit is going to use 2 units, 2 hours of laborer A, low skilled labor, 3 hours of laborer B, high skilled labor. And at these standard prices, or SP if we want, keep the terminology the same. So we're going to multiply those out. So the idea is every finished goods unit is going to use $28 worth of input A and $60 worth of input B, just by multiplying the mix times the price, the number of units in the mix per finished goods unit. Sum those, and that right there, $88 is the price in terms of using the standard mix, in terms of these 2 inputs per finished goods unit. So I can follow, I'll expand this here. I can follow this. Like I said, it's really easy because finished goods per batch is 1 FG per batch. And 88 here is the standard price of a batch of input units, which meaning specifically at the standard mix. So this is our standard mix. And given these prices of each input unit, we have a total price of $88 per finished goods unit from all these input units at the standard mix. So this divided by that is our standard price at standard mix. Okay. Now we can just follow this equation up here. We grabbed all 3 of our necessary inputs. We'll highlight them, make that a little easier for us. For this equation, all 3 of our necessary inputs for that equation. So our actual yield equals, I remember the parentheses that time, but I forgot to put an equal sign. So I always forget something, apparently. So this should be our number. This is our yield variance. So that rules out 2 of the answer choices. Right? We have 176,000, 176,000. So we know it's not C or D here. And I know Canvas doesn't letter them or whatever, but I'm just going to call them that for reference. See, it's not those 2. It has to be one of these 2. And it's a positive variance. And in yield, that means it's what? Favorable or unfavorable? It's favorable. Yes, just in yield, got to reverse the polarity of your thought here. Reverse what you think is favorable, because we're holding constant the input units and letting the finished goods units be what varies between our budgeted amount, standard yield, and our actual amount. So we yielded actually more finished goods units than we would have expected given 150,000 input units. All right, so does that make sense? Okay. So maybe this is being too obtuse the way I put it in the textbook right here. The whole idea is you want to figure out that for every finished goods unit, what does that cost you in terms of input units? And just use the assumption of at the standard mix. Because our mix variance is going to handle the difference between the standard mix and our actual mix of inputs. Just assume for the yield that we'll use the standard mix. And given that standard mix, it should cost us $88 in input units per finished goods unit. And I know this seems a little unnecessary for all that. You can logically get to here and understand that's SP at standard mix, then great.
Will it always be that total price for one finished good per batch, or will it ever?
I don't think I have. I'm pretty sure I don't have a question that has a batch greater than one. I think I phrase it this way because you could generalize this type of calculation to say, well, we used 1,000 input units of type A, we used 2,000 of type B, or sorry, the standard mix is 1,000 and 2,000 to generate 500 finished goods units. And from that, you can figure out, oh, it's 1 to 2 standard mix for 500, 1,000 to 2,000 for 500 units. And you could then do the division to figure out how much it is per one finished goods unit. I don't think I have questions that ask that. Am I wrong? Anybody seen that? Where I have a big batch of finished goods units, you have to figure it out on a yield variance question? I don't recall having that. I give you mixed variance questions that almost take that flavor of, oh, here's our actual mix, 4,000 to 400, producing this amount of actual finished goods units. But I'm not asking you from this to get an SP at standard mix. When I ask you for the SP at standard mix, I'm almost always asking for a single finished goods unit, it's this and this at this and this price. This number of A, this number of B, at this price of A and this price of B. Yeah, Nathan.
So the difference between 12,000 and 10,000, those are composite units. And if we were given that information, we would multiply by 2 for you to get the A and B inputs.
If we were doing like a chapter 3 kind of
Like if we were going back.
Yeah. You could divide it out into we overaged this much, or this much of the yield variance is due to A, and this much is due to B, the two different inputs, and get dollar amounts on that. You could do that, yeah. Heather?
So is there ever a reason why when you're trying to get the standard yield, you can't just take the actual input and divide it by the standard total input? To eliminate the 1 divided by 15 times it? Is there a reason why we couldn't just do that?
This divided by the total, divided by what?
When you're doing the standard yield, we're doing like 1 divided by 15 times that.
Mm-hmm. Where's right here?
But that's also the same thing as the 150.
This divided by 15.
Right. Is there a reason why we couldn't just do that? Like,
No. There's no reason. No.
Okay.
And it's what it ends up being. I'm like I use that word for myself, obtuse. I was being a little obtuse in how I've written this out, which is adding extra steps, which is making it harder for you to find out the flow chart you need to solve the problems. But yes, so all I'm saying is we have a number of finished goods units, which is, I think in the questions I've written them as always one finished goods unit per, in this case, 15 input units. And we're going to multiply that by the actual number of finished goods units. So we can almost, because assuming I am correct that I'm always saying it's just 1 per 15, you can just always have the actual input units divided by how many input units there are per finished goods unit that I give you, the 15. Yeah, and that's the other question. Yes, you can always do that. Yeah, Jesse.
For you, what do we compare to figure out the payroll and
So it's the actual versus the standard. I mean, you could either memorize the signs, which is not always what I do, that's not my natural inclination, at least. And then with yield, it's the opposite. Everywhere else, positive was unfavorable. With yield, positive is favorable. Or you can do the same comparison, but know that you're comparing actual finished goods units that we spit out of the process versus what we expected to be spit out of the process. We got a lot more out of this than we thought, and that's, I guess, what we think of as the favorability. That's the logic. I don't know if that articulation says it clearly enough for you. That's okay?
So standard is higher than actual is unfavorable?
Yeah, with yield variance, yeah. We expected this number of input units to generate X finished goods units, but actually it generated this number. That suggests we wasted a bunch of input units and didn't get out of them the finished goods units we were expecting. Probably a lot of rework or scrap involved in that. Or direct labor hours, a lot of direct labor workers messing around or not knowing what they're doing as well as they should. It's an indication of something like that, typically. Okay, let's move to a mixed variance here, I think. And this is basically identical, just different numbers to question 4. So let's find a mix variance. I think we'll have to go into the multiple choice, and then we'll make sure we get the open answer in the overhead, the 2 open answer overhead questions. All right, so mix here, we're going to build. So we kind of built a little table right here. Which is very similar to what we do with mix. There's a table involved at the very least. So we have a mix MCQ question, multiple choice question. How do I write that? Yeah. And we want to know the mixed variance. So mixed variance is going to be the difference between what we expected to spend at the standard mix, what we actually spent given our actual mix, but still some standard assumptions in there, versus what we expected to spend at the standard mix and those same standard assumptions. Maybe that's not making it very clear, but it's this, which is our actual input mix times our standard price, versus this, which is our standard input mix times our standard price. And sure, actual total input units is there, but some of you will do better not to think of those problems that way. So let me build the table. That's my favored way of doing it. So we have peanuts and candy and trail mix. I didn't just use that example during the lecture when I was talking about it. I used the example. It seems to me pretty clear. You only have so much space in a bag of trail mix, and so the inputs you put in there are substitutable, peanuts and candy in this case. And so we use 15 pounds of peanuts for every 1 pound of candy. Typically, the firm uses. What's meant there is you're supposed to interpret this as the standard mix. That's our standard mix. Perhaps it's not said as clearly as you'd like, but that's going to be our standard mix. So we have peanuts. Nope, wrong window. We have candy, and we're going to build a table and we'll get over there in just a second. And over here is where we have that standard mix. We have actual total inputs or input units times the standard mix, and then times the standard price. So this is over here at the standard side. We have a standard mix of 1 to 15, or rather 1 out of 15. We want it in decimal form so we can multiply it nicely. Versus, did it wrong. 1 out of 16. So we have total of 16 pounds that we're talking about here in this sentence. 15 plus 1. And so let's just go ahead and do that mathematically in the table. Now, here. So I'm battling with this here. No, copy. No. There we go. So these are our decimal forms of the standard mix here. So we can kind of have a pre-table, if that helps just organize it. We got our standard mix of 15 to 1, 15 pounds of peanuts. Oh, I did it backwards. Oh, look at that. 15 to 1. There we go. So that's total 16 pounds. And so we have 93.75%, or decimal form 0.9375, is our ratio of peanuts to 0.0625 or 6.25% candy. So we can just we can reference those over here, and I'll do them in the right order this time. Peanuts was the larger of the two, 93.75% peanuts versus 6.25% candy. Great. Now, for every mixed question, this is giving away a little part of the game. Just ignore the actual prices, because you're never going to use the actual prices in the mix variance. That's over in the price variance land. Mix is at most going to help get us to the quasi-budget, to get the quantity variance. Quantity breaks out into mix and yield. variances. So we're not even anywhere near actual price being used. So it's all about these standard prices right here. All right, so let's put those in. 13 for peanuts and 20 for candy. And we can put those there and over here. Now, we actually used 4,000 kilograms of peanuts and 400 kilograms of candy. Now, I'm being funny here, aren't I? So I'm using pounds up here. I guess our standard was built in America, and our actual units were produced anywhere outside of America that uses the metric system. Honestly, I don't think that was on purpose. But it's okay. We're talking about ratios in both these instances, so it doesn't matter the units. The term of art I'm trying to find. Anyway, it doesn't matter the units, what exactly the measurement is. We're talking about 4,000 to 400 being our ratio here. So in our little mini table, we have 4,000 kilograms, or 4,000 of whatever units we're talking about, versus 400. So we can do the same thing and sum those two, 4,400, and do the same thing here. I got to fix this. It's going to be E41. And say, well, that 4,000 is 90.9% of the mix. And that candy, 400 here, 400 kilograms of candy is 9.09% of the total amount of inputs used. So right here we can tell our actual mix favored candy over peanuts. We actually know from now, right from here, that it's going to be a favorable or unfavorable mix. Which of the two is more expensive, candy or peanuts? Standard price here. The candy is more expensive, and we used more of it than we should have. Our mix shifted, or it biased towards the more expensive of the two inputs. That means our mix has increased the price of our inputs here, the cost of them for us. That means it's going to be unfavorable. So we can already knock out two of these. We know it's not any of these favorable variances. It's either 875 unfavorable or 625 unfavorable. And yeah, we'll just stop there. We'll say that. All right, great. We can put that in. We can put the actual mix in right here. No, not minus. There we go. Now, the actual input units, we're talking about the actual input units here. Not. Oh, I see. We're talking about, we actually input a total of 4,400 kilograms. And at this, the actual mix times the standard price, that means we actually spent, or we are at the standard price, we would have actually spent $52,000 on peanuts and $8,000 on candy, for a total of $60,000 for those 4,400 kilograms of inputs.
Wait, I have a quick question.
Yes.
Sorry. I'm confused a little bit on how you have actual mix as the 4,000 to 400, and then you also have actual mix as the percentages. So is it like if the 4,000 to 400, those are just the ratios? I think I'm still confused by that.
Well, I'm doing an extra step ultimately. Sorry, let me try and answer that by kind of circumventing. We could collapse these two into just putting in the actual amounts, and we end up with the same number, 4,000 and 400. So our actual peanuts is 4,000 times the standard price 13 gives us this. Our actual candy is 400 times the standard price 20 gives us this. And it's the same number as when we had it all spaced out with this ratio. So I don't know if that helps answer your question. I am explicitly and numerically showing why this is different from the standard mix. So this is expressing the mix by these two numbers. So ultimately, I'm going to collapse this expansion that I made mathematically here. I'm going to collapse it by multiplying across here, and we end up with here ends up being 40,000, or excuse me, 4,000, and here ends up being 400. We multiply those two together. That doesn't directly answer your question, but you either seem to have had an epiphany when you were looking at it, or something I said helped.
Yeah, I just saw the actual mix on like the column. Yeah, I think I figured it out. I saw two different numbers. I looked it wrong, so I think I
Okay.
figured it out.
Okay. But what you said, and then me following up, maybe if that helps it be easier for you, you can do it this way. Peanuts, candy, times the standard price. Great. The trouble is over here, you do have to do it this way. You have to say, given 4,400 as our actual total inputs and the standard mix, we should have used 4,125 units of peanuts and 275 units of candy. That's what we're doing here. We have to come up with these standard amounts at the standard mix. So this side's a little harder to kind of collapse away. So I'm going to get rid of that. Delete that column, yes. Okay, let's multiply across. Okay, let me zoom out. Oh. And shrink some columns. And I'm just going to have to make it bigger. That's fine. All right, so we have our actual side over here, which we could condense right here. We end up with the same number, 60,000, excuse me. And we should have spent $59,125. So actual mix number minus standard mix number gives us 875, which is one of our answer choices. And we know that that's going to be unfavorable, both because it's a positive number. Okay, so mix follows all the other variances that we've done. Positive numbers are unfavorable, negative numbers are favorable. Really, the only one that we're going to flip is that yield variance, because it's just weird. It's positive number, unfavorable. It's harder to eyeball it if you collapse it like this. Like I was able to eyeball and say, well, that actual mix clearly is favoring the more expensive of the two. Like I said, it doesn't matter that these are in pounds because it just gives us this percentage ratio of what the standard mix is. So that when we have 4,400 kilograms, we know that we should have 93.75% of those kilograms be peanuts and 6.25% of them be candy. So it doesn't matter that we are using a different scale of measurement in the actual units here versus how I express the standard here. I don't think I meant for that to be part of the thing you learned from this question, but that is what it is. That is one of the things you can take away. Unfavorable, right? So let me poke around for another minute and see if I can find a way to show if you want to economize your process at this kind of question. You don't like building the tables out. It doesn't make sense to you or whatever. You can use this right here, the equation, and that is a little more condensed. So for peanuts, so this summation means we're going to have this equation for peanuts and this equation for candy, and we're going to add them together. So for peanuts, we have actual input quantity of 4,400. Excuse me, 4,000. There we go. It's from the problem, 4,000, right here. We have standard mix, and we get the percentage here. Or we could calculate it fresh of 15 divided by 1 plus 15. from this right here. Of the 16 pounds talked about in this sentence, 15 of them are peanuts. And we get the same number right there. This is percent peanuts at standard mix. And so we can multiply those. No. Plus. We're going to repeat some of the. I'm repeating some of the action we did up here. Just different process now. This is our total inputs, and we can multiply that out to get our standard input quantity. Okay, this is somehow clearer to you. That's great. So we should have had 4,000. We actually had 4,000 kilograms of peanuts. We should have had 4,125 kilograms of peanuts given our 4,400 total kilograms of trail mix that we made. And so we can take our actual minus our standard, just following this equation right here, and multiply it by the standard price for peanuts, which is $13. In fact, let's go ahead and put that here in our process. Let's copy it over from the question. $13 is our standard price, and so let's reference that right here. So that is going to be a favorable kind of subvariance. We saved some money by using fewer peanuts than we expected in our mix. We saved a little bit of money, but we're gonna have wasted more money than that by using more candy than we expected. So candy, we have actual input quantity here. We can say 1 out of the 16 pounds talked about in the mix sentence should be candy. This is percent candy at standard mix. We have total inputs. It's the same. We have 4,400 total inputs. And so we multiply those two together. This should be our standard input quantity. And our standard price per the question right here is $20. And so we can follow the equation and take our actual input quantity minus our standard input quantity all times the standard price. And so that's our unfavorable candy variance. And we just need to sum these. This is unfavorable mix variance. So if that helps you, you can go this route and reuse some of the procedures you use for typical quantity variances. Actual minus standard times standard price. An actual quantity minus standard quantity times standard price. You just do that for every single type of input, where standard input is given the standard mix and the total input. This is how many you should have used the peanuts. That 4,400 should have been 4,125 peanuts. That 4,400 should have been 275 candy. That's your calculating the standard that way. As long as you can get that added, then you just also have to remember to sum them at the end. This favorable peanut quantity variance, as it were, this unfavorable candy quantity variance, as it were, gives a total of 875 unfavorable mix variance there. Okay, let's jump over, make sure we get some overhead in here. All right. Try this. We got two open answer ones here.
Can I ask you a quick question?
Yep.
Just on that last problem.
Mhm.
Where did I know you probably said it, I just missed it. Where do you put the actual price? Does that not matter?
Doesn't matter. Any of the mixed questions, you can ignore the actual price.
Okay. It doesn't even matter on like if you're finding the actual mix or
Nope.
Okay.
Yeah, because I say it. I don't. Maybe it helps if I draw it out. Over here is where we're going for price variance. So we're going to go from some sort of standard price to an actual price to get the price variance. Over here in the mountain range is the quantity variance, where it's still at standard price, but we're switching actual quantity versus standard quantity. And my point is that both the mix variance and the yield variance are just coming out of the quantity variance. So they're all over here where we're all at standard price, if that makes sense. So yeah, we're all these things are written at the standard prices for the inputs. We're not yet pulling any levers to get over to actual price. So every time you see actual price and we're talking about mix or yield variances, that's a red herring. It has to be. All right. So variable overhead quantity variance. Let's go over this really quickly. I think we can do it with speed and precision. We got both those in there. So VOH quant variance. It's a quantity variance, so it's actual AQ minus SQ all times standard price. Just what AQ is and SQ is requires a little bit of interpretation. In terms of quantity for variable overhead, we're talking about quantity of the cost driver. So actual quantity of the cost driver versus standard quantity of the cost driver. And standard price is going to be our variable portion of the predetermined overhead rate. We're charging a certain amount of predetermined overhead rate, we're charging a certain amount, comma, a predetermined overhead rate for overhead, for every unit of cost driver, to allocate overhead, that's what I'm saying. And some portion of that is for variable overhead. I'll give you percents right here, and that's how we figure this out. So let's start with actual quantity. We're going to chop up. No, let's just read through the problem like we're normal human beings and start where we really should start. Be they whatever order from the equation that we can. So this question starts with price stuff and says, look, we have a PDOH, which is our standard price for both types of overhead, and it's $14.92. All right. So we can start with that. We're going to be multiplying that by a percent. 1492 is our overall PDOH, and 55% of that PDOH is for variable costs. So we can multiply that 55% in decimal form. 1492 times 0.55 should give us our, also called PDVOH, predetermined variable overhead rate. So $20.6 or $8.206, there we go, is the variable overhead cost we charge per unit of cost driver, given this fact pattern right here. Okay, that's our SP. And we have actual quantity and standard quantity we can figure out. Our actual quantity of driver consumed is often given to us. Oh, there we go. 3120 units of cost driver were actually consumed. Okay, great. We can just copy that over. Nice and easy. Great. Now, SQ is going to require a little bit of help. We have a standard of 2.5 cost driver units per finished goods unit, and we actually consume 665 finished goods units. So our standard quantity is always the one we want to use for the quantity variance is always the flexible budget standard quantity. The standard quantity of what we would have used at actual production. What we would have budgeted if we knew the actual production was 665 finished goods units. Who cares that static budget said you should use 2430? Static budget was based on what we thought we were going to produce in finished goods units back at September of last year. Given that we actually know we're going to produce 665, we would have budgeted, hold on, 1,662.5 as our standard quantity of cost driver for this period. So we can follow the equation now, just plugging in the variables we typed out. So that should be our variable overhead quantity variance. Now, what if it were asking for variable overhead price variance? I think we actually have enough that we can solve for that. So, Jack, you had said that sometimes I give this one right here and it can be confusing. I can't necessarily change the wording, But whenever I say you actually incurred this amount of costs, I think I'm successful at least 90%, if not 95%, or even 100%. I don't know. To say when I'm talking about costs, this word costs, I try to reserve for the total amount. I try to do that. At least when I'm thinking about it. It's this total box, which SQ times SP, or in this case, actuals. It's over here. The total box of AQ times AP. So I try when I say cost, you incurred this amount of costs, or you should have incurred, the standard was this amount of costs. I try to reserve that word cost for total costs. And maybe I should even put in total to make it even clearer. Because I don't think this is where I'm not trying to trick you necessarily about what I mean by that. It's not really what I'm saying more kindly. It's not really a pedagogical learning objective that you know that I mean total costs when I say costs in this instance. So perhaps I can revise in future semesters or between now and the final, maybe insert total costs in there to make it a little clearer that that's what I'm referring to. So in this case, we have our actual quantity times actual price given to us. And we also know our actual quantity, so we can get our actual price out of this. This 18,964 divided by 3120 will give us our actual price, right? We have actual quantity, so the total cost, which is actual quantity times actual price. And if we divide that by the actual quantity, we should be left with the actual price. Those cancel out, we just left with the actual price. So total actual costs of 18,964. And we have actual quantity of 3120. So we can divide that, and we get actual price of $6.07.8. We need that because we need to figure out actual price minus standard price times actual quantity for our price variance. And so we can now solve the problem because we already figured out the standard price way up here. So we have those numbers. We have all three of the variables in the equation. Great. Actual price of $6 and change minus standard price of $8.20, all times the actual quantity right there. So that would be our variable overhead price variance. So some parts where it's tricky to interpret the fact pattern and put it into the equations. There are, first of all, what is standard price? What is standard quantity? What is actual quantity? And then I might have costs, meaning the total costs that you have to divide out to get the actual price in this instance. So with variable overhead, just remember, when we're talking about price, we're talking about the variable portion of PDOH rate, the PDVOH. When we're talking about quantity, we're talking always about quantity of the cost driver, the actual cost driver used, or the standard cost driver that we would have used at actual production here, the flexible budget standard. All right, let's try to slip over here and see if we can get this done before 2 minutes have elapsed and we turn into pumpkins here at 4:15. So here you have an FOH volume variance question. Open answer. This was also open answer. Just be consistent. So the volume variance, we'll go down here. It's the little one that's kind of weird we're up ways. That's right here. Taking the static budget minus applied cost. And looks like I successfully updated the equation right here. Static budget minus applied cost. So the static budget box is static budget cost driver times predetermined fixed overhead rate. So the fixed portion of the predetermined overhead rate. And this applied cost number is actual cost driver, actual quantity right there, times PDFOH, which is the budgeted or standard price. So standard price in both instances, just differentiating between standard amount of cost driver on static budget versus the actual cost driver, which is what we will have applied the costs on, which gives us this number here. A lot of words. Let me shut up about that and do what we've been doing before. We're going to take this. We need a standard price, and it's expressed very similarly. It's 18.65 times. Now, 49% is for variable overhead, which means that 51% have to be for fixed overhead. For fixed overhead. So our PDFOH, or standard price, is 9.5115. All right. Now our budgeted quantity was 2446. Our actual quantity of cost driver, actual quantity here, is 2446. No, 1766. I looked at the wrong number even though I highlighted this 1766. So we can create the squares. Usually I use the equation, but we can just create the squares. This is the static budget amount. We would have budgeted $23,265 and change on the static budget for fixed overhead costs. And we would have applied $16,797 and change here. So we can now subtract these two, and we get 6467.82 as our volume variance. So let's make sure, just before we go, let's make sure we got all these right. Hope I did. So I should get 7.5 points. Okay, good. All right. If there are particular problems giving you trouble, email me before Friday, and we'll help. I'll try to get it sorted out as quickly as I can. Get back to you. Thank you very much.